I'm Anil Kumar. Welcome to my series on matrix. Here we'll discuss linear transformations of vectors, which is a very important application of matrices. In this video, we'll discuss how do we find the projection onto the x-axis, projection onto the y-axis. What you should know to understand this topic is the matrix multiplication, which I've shown right here. Here's a 2 by 2 matrix. When you multiply by 2 by 1, this is the result, right? A 2 by 1 matrix. So when we are talking about projections, let us say that we have a matrix A here and a matrix X there. So when you multiply, you get the matrix AX. Now what we will see that this is a transformation. So since we are taking X and Y in this column, it basically represents R2. So in general, you can think about a transformation in R2, right? So you can think about a transformation in R2, where the transformation matrix for us is this AX, right? So the transformation of X is this, which is AX, right? So that was kind of technical. Now let's look into the geometrical view of what are we trying to figure out. Let us say that this is a X and Y coordinate. We'll actually restrict ourselves to vectors. Now, if vectors is confusing for some of you, you could consider even the points, the head of the vector. So let's say a position vector here, where this position is, let us say, 2, 3, the point here. So when we say projection onto the x-axis, it means what? It basically means that if I have something here, then the shadow of this falls right there. So that becomes the projection on the x-axis. You get the point. If this is my point P, then the projection here on the x-axis will have the same x-coordinate, but y-coordinate will be 0. So I'll get 2, 0 here. So that could be a linear transformation, which we are talking about. And in this video, you will learn what should this matrix A, that 2 by 2 matrix should be, so that we could get projection of all these points in our plane on the x-axis. So, in general, let us say if I have a point somewhere here, let's take a point here. In general, if I have a point xy, then its projection on the x-axis will be what? It will be x0, right? So for any point, projection on the x-axis will basically make the y value as 0. Is that clear? So this is what we understand with projection on the x-axis. Is that clear? Now let's look into the projection on the y-axis. So when I'm saying projection on the y-axis, what I'm trying to say here is that now a point, let us say we have another point here. Let's take this point as let's say Q. Okay, so let's say this point Q is basically, let's say 4, 3. In that case, projection of this point on the y-axis. So this is your x-axis, this is your y-axis. Clear? So projection of this will be here, right? That point. Now if you see, Q dash in this particular case will be what? The x value now becomes 0 and the y remains same as 3. So that becomes the projection on y-axis. Is that clear? Clear. So that is what we are going to explore, and this is projection on the x-axis. So let me write down. So graphically, I think the concept is clear, right? Now let us see how matrix help us to understand. Now in this series, we will see all kinds of projections and we'll develop a method of finding this transformation matrix, which will always be 2 by 2 matrix, correct? So let's see, how should we do it? And what you really need to remember is this simple multiplication, which is a 2 by 2 matrix times 2 by 1 matrix, xy, will be ax plus by, that comes as your first row, and the second row is the, you can say a scalar multiple, right? Cx plus dy, right? This is what you get, right? So you could also think about it like x times AC, this first column, and y times BD, the second column. So that's a very good way of looking into it. Now this particular concept will help us answer the question how to create a 2 by 2 matrix and get our projections, right? So let's move forward and then take some examples to illustrate the whole idea. Now to understand how to develop our 2 by 2 matrix which could perform projection onto the x-axis, let us further explore. So let's consider again the xy plane and some points on it. So here we have, let us say, a point P whose coordinates are, let's say, 2, 1, let's say, okay. So when I project this point on the x-axis, the coordinates here becomes the x value remains same, which is 2, and the y becomes 0, right? So this is 2, 0, correct? So that becomes a projection of the given point on the x-axis. Is that clear? Okay. So that is the x-axis and that is the y-axis. Let's take another point. Let's say we have a point Q here, and let us keep it general. Okay, so we'll just say this point is x1, y1, correct? So the projection of this on the x-axis will be a point which is x1, 0. So that is the point Q. Now the idea is, how do I write a transformation matrix 2 by 2 to get a projection of a point on the x-axis? That is what we're trying to figure out. So let's carefully look into what we have here and try to figure it out. So let's draw a parallel here. So we need to fill out this particular matrix. We know what xy is and also what we are expecting from it after transformation. So taking the first example, which is 2, 1, we know this is 2 and this is 1. And what do we need? Our result as we need 2 and we want to make this as 0. So if that is the case, what should be this matrix A which can perform this kind of linear transformation? That is the question. Okay. Now, as you can see here, the result is 2 on the top. That basically means, and the result here is 0. That means C and D should be 0, right? Clearly. So C and D being 0, I will place 0 here, right? So we have zeros on this side. That ensures whatever this point is. So what we will do here is we'll also look into our general point. Correct? And see whether the formula which we are developing using this transformation matrix works in general or not. Right? So we have a point here x1, y1. So if I have these two as zeros in my 2 by 2 matrix, then I am sure the result here will be 0. Now identity of x is to be maintained. That is the key. 2 remains 2. So that gives me an option 1, 0. You get the idea? So the identity matrix helps us to get that idea. And as soon as we place 1 here, we do notice that both the equations are satisfied. So we do get x1 here. You get it. So this 2 by 2 matrix which we just developed, which is basically 1, 0, 0, 0, helps us for a vertical projection onto the x-axis. So that provides vertical projection onto the x-axis. Is that clear? Is that clear? Correct? Now later we'll also see that it is not just the points which are being projected. Let's look into it in another fashion. Let's take here, which we are going to also work separately. If I have a line going through these 2 points, for example, then the projection of the points will be right there. So what do you get? You get the projection of the line on the x-axis. Does it make sense? So this transformation matrix will project a line also on this. So what you need to explore here is that if I have a line which is x0, y0 plus t times, let us say d1, d2. In that case, this line will also be projected along the x-axis using the transformation shown here, 1, 0, 0, 0. Perfect. Is that clear? Since every point will be projected on the x-axis, so the 2 points defining a line will define that line on the x-axis. Does make sense to you? So I hope this concept is clear and simple. So projection on the x-axis basically means looking into this transformation matrix where A is 1 and all others are 0. Correct? So with this idea, let's move on and understand what is projection on the y-axis then. So I hope you have understood what is projection on the x-axis. Now let's talk about projection onto the y-axis. So we'll take a similar example here. Let us say we have a point, right? So the coordinates of this point, let's say P, is, let's say 2, 3, right? Okay. So when we say project this point on the y-axis, what does it mean? It basically means that we want to see its image on the y-axis, so we want to see it right there. So here the coordinates of the point are clearly 0 and 3. The y coordinate remains exactly same. Now in all linear transformations, the 0 is always projected to 0 itself. Does make sense? And therefore the position vector OP will now be projected on OP dash. Does it make sense to you? So that gives you a clear idea that any vector could be projected on the y-axis, and that is what we call projection on the y-axis. Now what are we looking for? We are looking for this 2 by 2 matrix which we can perform vertical projection. What should it be? So let's look back into the combinations which we have. So if I have a point 2, 3, so what we have here is a point 2, 3, and what do we want as the end result? The end result which we want is basically 0, 3. So for that, what kind of transformation matrix can we have? We know 2 by 2 is a linear transformation matrix. Now, you could consider either one of these combinations to get your result. So clearly, since we want 0 there, these two should be 0. Only then that combination becomes 0. Right? Now here, you want this to be 3. So to make that 3, look into the identity matrix, and then we want this y value, right? The same y value. So it makes sense to try this out. Correct? So the y value, b to d, right? So what we get here is b is already 0. You have no other option than to put d as 1. So combining these two really gives you insight to this. Right? So we know we want to make 0, so these two are 0. That means b is 0. Now for y, b is 0. What are you left with? Just the point d to work with. You want 3 as 3, so that has to be 1. And that gives you an idea that we could have scaled it also, right? Now at present, we are just doing projection, so it has to be 1. Perfect. Does it work for you? I think it does. So let's try it out with some of the examples. Let's say we have, let's call this as example 2, where we have a matrix which is 0, 0, 0, 1, and let's take a point which is minus 3, and let's take this as, let's say, okay, let's take both negative. Minus 3, minus 4, since, we have some room here. Okay, so if I do this multiplication of matrix, what do I get? I get 0 times minus 3, right? So 0 times minus 3 plus 0 times minus 4, which is indeed 0, and then I get 0 times minus 3 plus 1 times minus 4, right? So what we get here basically is 0, and we still get the value minus 4 for y. So what we are trying to say here is that if we have a point minus 3 and 4, let's say we have a point here, minus 3 and 4, right? Then its projection will be this point here, which will be at minus 4. Let's say this point is Q. You get an idea, correct? So that means in general, our matrix, which is 0, 0, 0, 1, right, working on any x and y point in R2 will result into what? Will result into the same value of y but 0 for x. So that becomes your matrix which could do the projection onto y-axis, right? So that is your horizontal projection onto the y-axis. Is that clear? Perfect. So that is how we can visualize it, see it geometrically, and develop our matrix. I hope you're getting insight to it. Now let's look into the line as such. Now let us see how do we project a line onto the x-axis. So let's try to understand what are we trying to say here. to keep things very simple, let me say we have a line kind of like this. Now, we'll take some concrete points here. Let's say this is just point 1, and we could describe this line R in the vector form. We'll describe this as 0, 1, right? That is one of our points, the y-intercept, plus it rises as, let's say 2, 1. Okay. So where t belongs to the real numbers. So that is the equation of our line. Now, a general point will be given as what? The x value will be 0 plus 2t, right? And the y value will be 1 plus t. So that becomes a general point on a particular line. What we just learned about projection on the x-axis was that the 2 by 2 matrix, which can do this projection, basically, is 1, 0, 0, 0. Correct? So when you have any set of points on this, let us say x and y, the result is x and 0, correct? So that means if you are looking at these points and their projections, then this point will be projected right there at the origin, and any other point here will be projected on the x-axis. So that gives you a line joining these 2 points. Does it make sense? So that is your scalar projection on the x-axis. You get the idea. Right, so that is basically the projection of the line onto the x-axis. Is this concept clear? What we need to check is whether this transformation matrix really works for a line. It does work for a point. We just saw it, right? So we're considering a point here, which is 0, 1. And we have another point here, a general point here, which could be written as 2t 1 plus t. So that becomes a general point. So we are going to apply this transformation to a general point and check our result. Is that clear? So let's do it. So we have this transformation matrix, which is 1, 0, 0, 1. And now we have a point here, which is 2t 1 plus t, and when I do this, what do I get? So 1 times 2t, right, plus 0, okay, and here we get 0 times this, which is 0 plus 0, so that basically gives us 2t 0 as a new point. So 2t is the x value and 0 is the y value, so we do get this point q as q dash. You get the idea. Any point on this line will have, if t is, let's say, 0, then if t is, let's say, 1, so somewhere here t is 1, let's say 2 and 3, that will also be projected on this line. So accordingly, if t is 0, we have 0, 1, the y-intercept, which projects to the origin itself. Is it okay? So taking that into consideration, what we see here is that the transformation matrix 0, 1, 0, 0, 0 also projects a line in R2 on the x-axis. Does it make sense to you? Correct? So for practice, I would like you to work with these examples, that is, find projection of the following points on the x-axis using the transformation matrix A, let's say A. We'll call this matrix as A. Is it okay? And for example, you could do points -3, 1, and you could do points 3, -5. Correct? So try this out. And also figure out whether this line joining these 2 points can be projected on the x-axis. Okay? So let's move on and see now projection of a line on the y-axis. So now let's further explore projection of the lines in R2. So what are we trying to figure out this time is that if we have a line which is, let us say like this. In that case, if I want to project this line on the y-axis, what kind of transformation matrix is required? So what we figured out in the very beginning, that we want the values for x and y to become 0 and y. Correct. That is what we are looking for when we talk about projection of lines onto the y-axis, right? So basically, we are saying that if I have a point here, it will be projected on this line, this will remain here, and that point will get projected on that line. So what we get is this line. Correct? If you're talking about just a portion of it, a segment, then you could see that part of the segment on the y-axis itself. Does it make sense to you? Correct? So that's what we are looking for. Now, seeing the transformations, the multiplication rules, we want x value to become 0, and that is what the combination could be. So clearly, these two values here should be 0. Only then you get the x value as 0. Does it make so? A and C, so A and B should be 0 to get this 0, right? Okay. Now, you got B as 0. For y, this combination should be y. So how can this be y? It could be y only if d is 1. So we get 0, 1, and that becomes a transformation matrix, which could, when multiplied by x, will give us ax of this form. Perfect. So the transformation matrix which we learned helps us to also transform a line segment or a line on the y-axis. Right? So that is the projection of a line on the y-axis. Is that clear? So, as we can take one particular equation, for example, the equation of a line, let's say, has got a point here as, let's take this point as, let's say, 0 minus 2, right? Plus t times, let's say, is going up by 1 and 2. Okay. So that could be a general point on our line. So the x value in this case will be 0 plus t. The y value in this case is going to be minus 2 plus 2t. Correct? So that becomes a general point for us. So we have a point which is t and minus 2 plus 2t. Using this transformation, what do we get? Let's try it out. So using this transformation, which is (0, 0, 0, 1), the point for us is t minus 2 plus 2t. What do we get? So when you do the multiplication of these two matrices, you get 0 right there, and here you get minus 2 plus 2t. So every point on the line is mapped on to the y-axis. So that is your projection on y-axis. Is that clear? So this particular matrix, this 2 by 2 matrix, So this 2 by 2 matrix can project a line segment onto the y-axis. So that is where we started with, correct? So what we learned here is that for projection on the x-axis, the magic is done by the matrix, which is, since we are doing it on the x-axis, it is 1, 0 and 0, 0. And for a projection onto the y-axis, it is 0, 0, 0, 1, right? So these are the two matrices which can help you project any point on the x-axis or y-axis. So that means set of points, and that means vectors, and that means lines and segments. So I hope that helps. Feel free to contact me on the given address. If you like, you can subscribe to my videos, that'd be great. Thanks for watching and all the best.